Hi everybody, today we are going to solve equations by factoring or our quadratic form. So let's first start off with our factoring, and this will kind of feel familiar to other things that we've done in this class. So we're going to start with 7x cubed minus 21x squared plus 14x equals 0. So even though this is power 3, I can quickly turn it into a power 2 just by dividing out an x. When I go to divide out the x, I also want to pay attention to the fact that I have a 7, negative 21, and 14. So all of these coefficients also have a common factor of 7. So I'm going to factor out 7x, then I'll be left with x squared minus 3x plus 2 is 0. So I'm going to keep that 7x. Then I'm going to look a little harder at x squared minus 3x plus 2. Factors of 2 that give me negative 3 would be minus 1 and minus 2. So I have three factors. 7x is 0, x minus 1 is 0, and x minus 2 is 0. This says x is 0, then x is equal to 1, and x is equal to 2. So I have three solutions, 0, 1, and 2, to this equation. In the next one, I'm going to factor by grouping. And I know to factor by grouping because there's four terms. I have x cubed plus 4x squared minus 9x minus 36 is 0. Will everything factor by grouping? Absolutely not, but I would say in this section where you're trying to look at other ways to solve equations that most of yours are going to come out that way when you get four terms. So we're going to take the first two, and then we're going to take the second two, and we'll just look at them individually. So with x cubed plus 4x squared, I notice they both have an x squared. I'm going to factor that out. I get x plus 4. The second two, I have negative 9x minus 36, so I'm thinking they're both negative. Let's take that negative out, and they're both multiples of 9, so I'm going to take out a negative 9, and when I factor that out, I get x plus 4 again. So that was negative 9x over negative 9 is x, and then 36 divided by negative 9 is 4. And here's where the magic happens, is that I have this x plus 4 twice. It's the same, so I take it out, and I'm left with x squared minus 9 is 0. So power 3 equation, I'm expecting three solutions. So I have x plus 4 is 0. I have x squared minus 9 is 0. So the first one, I get x equals negative 4. Then I have x squared equals 9. Remember, when you take the square root, you're supposed to put on that plus or minus in front of the 3. So I have three solutions to my power 3 equation. Now we're ready to move on to something a little bit bigger, and what is called is quadratic in form. An equation is quadratic in form if it can be expressed as a times u squared plus b times u plus c equals 0. The a, b, and c are real numbers, and u is an algebraic expression. Notice I have three terms here, so it looks like a trinomial. We've factored a lot of trinomials, so hopefully you make that connection too, that quadratics are trinomials. And then we're just going to look at, well, what will I do to solve that? So we're going to start with this x to the fourth minus 81 equals 0. And this looks like the difference of squares, so I try to start kind of easy. So if I think of the difference of squares, x to the fourth will split into x squared minus 9, and x squared plus 9 is 0. But I can go a little bit farther. X squared minus 9 is x plus 3 times x minus 3. Then I have x squared plus 9 equals 0. So I'm going to set each factor equal to 0. So x plus 3 is 0, x minus 3 is 0, x squared plus 9 is 0. That gives me x is negative 3, x is positive 3, and then x squared is equal to negative 9. So we're going to keep going. Nothing said that we were only going to get real solutions. I'm going to take the square root of x squared, which gives me the square root of negative 9. That says x is equal to plus or minus from the square root. Square root of 9 is 3, but because it was a negative 9, I put an I at the end. So my four solutions are 3, negative 3, 3i, and negative 3i. I'm going to write it in a set this time. The next one says x to the fourth plus 13x squared plus 42 is 0. So you can see it's quadratic in form. I have this trinomial, but what I want to do is show you how I could put that expression of u in. So if I said, well, if x squared is u, then u squared would be x squared squared, which is x to the fourth. So instead of writing x to the fourth plus 13x squared plus 42 is 0, I could write u squared plus 13u plus 42 is 0. So sometimes you find that that's easier. We could have left it with the x to the fourth. I could probably show both ways. So here I'm going to factor 42. Factors of 42 that give me 13 are 6 and 7. So I have u plus 7, I have u plus 6. But that says u plus 7 is 0, so u is negative 7. Then u plus 6 is 0, says u is negative 6. Well, now I need to go back and say, what did I start with? And I started with x squared. So x squared is negative 7, x squared is negative 6. I take the square root of both sides of each equation. I get x is plus or minus the square root of 7i. I get x is equal to plus or minus the square root of 6i. So there is one way to solve if you actually do the substitution. If you don't want to do the substitution, that's still okay. You could say x to the fourth plus 13x squared plus 42 is 0. Can be factored. X to the fourth would split to x squared and x squared. Factors of 42 are still 6 and 7, still addition in between, equal to 0. So this way, I have x squared plus 7 is 0. I have x squared plus 6 is 0. X squared is negative 7, that looks familiar. X squared is negative 6, also looks familiar. And then we take the square roots. So you do have these two choices. I like to show you both just because I know you could see them in the future. So a little early look at substitution is always nice, but you can of course pick which way you want to solve these equations. So here's another one, and definitely I'm going to go about the u substitution to start me on this one. I have x plus 2 squared minus 3 times x plus 2 minus 10 equals 0. So I said, let's do u substitution. So my u is equal to x plus 2. The u term should kind of like shout out to you what it is. It's usually like the middle term and it has a coefficient. And then the first term is that thing squared. But we'll do a couple more to really make it clear what the u is. So this changes into u squared minus 3u minus 10 is 0. I factor this. It's negative 10, so I know that I'm going to subtract the numbers, and I'm going to have 5 and 2. The bigger one, 5, will be negative. The smaller one, 2, will be positive. I have u plus 2 times u minus 5. I set that equal to 0. U plus 2 is 0, u minus 5 is 0. This says u is negative 2, u is positive 5. The key to substitution is always remembering to go back to it. So this says x plus 2 is negative 2, which makes x negative 4. The second one, x plus 2 is 5, says x is 3. The alternative this time would be to expand to say x plus 2 squared is x squared plus 4x plus 4. Distribute the negative 3. I have negative 3x minus 6, and then subtract 10. So I could do this if I wanted to, right? Nobody's saying you have to use the substitution. It's a choice, and hopefully you see maybe a shortcut. Then I have x squared. I had 4x minus 3x, which is just plus x. I have 4 minus 6 minus 10, so 4 minus 6 is negative 2, negative 2 minus 10 is negative 12, that's equal to 0. Now I'm looking for factors of negative 12 that give me 1, so that'll be x plus 4 and x minus 3, which says x is 3 and x is negative 4. So always choices, right? I like to give you choices and say do what works best for you. So this time I have x to the fourth minus 12x squared plus 27 is 0. Maybe I'll do it without substitution this time. But again, it's still quadratic in form, so I didn't change the quadratic part or the kind of thinking of it as a quadratic part if I don't do substitutions. I think x to the fourth is like x squared times x squared. Factors of 27 that give me 12 would be 9 and 3, and they're both negative. I know that because this plus sign says they're both the sign in front of the b term. This says x squared equals 3, x squared is equal to 9. When I take the square root of everything, I end up with x is plus or minus the square root of 3, and x is plus or minus 3. I hope you see the number of solutions is matching to the degree of the equation. So I have degree 4, I have 4 solutions. So this gets a little weird when I have 2x to the 1/2 minus 11x to the 1/4 plus 15 equals 0. I don't call things degrees when I have fractional exponents. Here's a good one to go back and try that substitution. And I said, how are we going to know what it is? So how am I going to know what the u is? I'm going to look for the middle term. So this is x to the 1/4. So I'm going to say u is x to the 1/4. And then I immediately want to find u squared. So that's x to the 1/4 squared. Remember, when I take an exponent and raise it to a power, I multiply the exponent. So I have x to the 2/4, which is x to the 1/2, which is really nice because that's my first term. So now I have 2u squared minus 11u plus 15 equals 0. Let's go back to the AC method where we take the coefficient of my first term, I multiply it by my constant term, so 2 times 15 is 30. I'm looking at factors of 30 that get me to 11. That would be 6 and 5. So I have 2u squared minus 6u minus 5u plus 15 equals 0. If you're worried that you might drop that negative sign for the 5, you might want to put the negatives into your factors to think negative 6 times negative 5 gives me 30, but negative 6 plus negative 5 gives me negative 11. You do want to pay attention to those signs because if not, it's not going to factor correctly. So let's take the first two, then the second two. The first two have a 2 in common and a u in common. So 2u into 2u squared is u. 6u divided by 2u gives me 3. Remember with the minus sign in between. Negative 5u plus 15, I'm going to take out a negative 5, and I get u minus 3. I need this to always be the same. If I don't have exactly the same, I can't go farther. So we're going to take out u minus 3. That gives me 2u minus 5 equals 0. So this says u is equal to 3. This says 2u minus 5 equals 0. 2u is 5, so u is 5 over 2. Now, we don't want to stop there because the question didn't start with u, it started with the x's. So I have to say, what was u? U was x to the 1/4. So x to the 1/4 is equal to 3. How do I find x? I raise both sides to the 4th power. We're always kind of doing the opposite. So 3 to the 4th is 81. There's one of my answers. The other thing I have is that x to the 1/4 is equal to 5 over 2. Again, I'm going to raise that to the 4th power. I do want to separate that. I want to make that 5 to the 4th over 2 to the 4th. So 5 to the 4th is 625, 2 to the 4th is 16. So here are my two solutions to this equation. So let's try one more that kind of looks similar. This time instead of halves and fourths, I have 2/3 and 1/3. U is going to be x to the 1/3. U squared then will be x to the 1/3 squared, which gives me x to the 2/3. So it works out exactly as we would hoped. So this becomes 2u squared minus 7 times u minus 15 is 0. Just like the last one, I'm going to do the AC method. So 2 times negative 15 is negative 30. This time I need the factors to add up to a negative 7. So that says if I use 3 and 10, I can see the difference is 7. I want to make sure it's a negative 7, so we'll make it negative 10 and positive 3. So let's write 2u squared plus 3u minus 10u minus 15 is 0. The first two terms have a u in common. I factor that out. I get 2u plus 3. The second two terms, well, they're both negative, so I'm going to take a negative out. 10 and 15 have a 5 in common. Negative 5 into negative 10u is 2u. Negative 15 divided by 5 is positive 3. Not a surprise that this 2u plus 3 matches. It factors out, and I have u minus 5. So this says 2u is negative 3, so u is negative 3 over 2. There's one solution. And the other solution is u equals 5. Let's go back to u is really x to the 1/3. So x to the 1/3 is negative 3/2. x to the 1/3 is 5. So to get rid of the 1/3, we cube everything. Don't lose that sign in there. -3 cubed is -27. 2 cubed is 8. Do the same thing with the 5, and I get x is 125. So 2 solutions this time too. So this was the last of our series of other types of equations. I hope you watched all of them to see what to do. I will link all of them together so that you know which ones you're supposed to watch to accomplish this section. Good luck.